Hello. Hey, my mic is on. That's awesome. Is the text here large enough? Do I need to bump sizes up or anything? I do things in HTML so that, you can do that shit. Oh, my clicker's not going, though. Let's get that fixed. You know what I didn't do? I didn't plug in the dongle. So, with a quick pause for dongles. There we go. Hi, I'm Miriam Suzanne. That is definitely a picture of me. And I'm glad to be here. Thanks, Jen. In case you don't know me, I run Oddbird with my brother. We're a full-stack agency, small team, doing client work for various people. I recently started learning JavaScript. Sorry, being introduced to JavaScript. It's the one language you cannot learn. Everything else is learnable. So mostly I've done lots of HTML and CSS and then dabbled wherever I need to. So I've mostly been known for Suzy, which I was told to use as an introduction because people might know it, even if you don't know me, and then show that it's got lots of downloads. But I don't want to do that. I want to tell you not to use it because grids are so, let's say, 60s, right? That's going back a little too far, but good. So while you were all surfing yesterday, I was just on my way here. Sorry I showed up late, but I'm here now. The TSA took my toothpaste, so you're safe. But fortunately, the hotel has given me some more, so you're safe. But let's talk about CSS, and we're going to start with a little bit of history. Thanks, Jen. So in 1993, we got the first HTML spec. This is my company in 93. We were just doing our first client planning, I think their card sort of some kind. A little bit later, we got the font tag and tables, which was great. We could start styling these documents that we had, these HTML documents. And in case nobody screamed it at you recently, yes, tables are for data. A little bit later, actually earlier if you're looking at when the spec was first released, but later if you're talking about when it was implemented in browsers, we finally got CSS, cascading style sheets. And HTML and CSS were both built around this principle of least power. What is the least powerful language we can build that will solve this problem we need? And that was a guiding principle of the design of these languages, which is important to know when we're looking at the history of them. So we got CSS, and it's awesome. Thank you. That's my talk. You've all seen this. You should know, I think that this is absolutely a feature. If you had a design tool that could not handle overflow of a box, you would ditch that design tool immediately. You need to be able to handle overflow. This is a feature of CSS, and CSS actually gives you various ways you can handle it, and that's good. The problem with this is just that a designer didn't look at it. Also in 2000, same time that browsers were picking up CSS, we got the Dao of Web Design from John Alsop. How many of you have read that article or know of it? A few. So that's an early manifesto saying the limitation of the printed page is that it's the same everywhere. And we have to stop thinking about that as an advantage of the printed page that we should achieve with CSS, and instead think of that as a limitation that we can now go beyond. We can start thinking dynamically. We can start thinking about how things are going to look for different people in different places on different browsers. So this is actually the first time we're talking about should everything look the same in every browser, and John Alsop says no. Around 2007 to 2010, and this is when I was starting my company, we got the major grid frameworks, Blueprint, OOCSS, 960. At this time, grids were starting to become popular. You had 12 columns, gutters between them. You were able to span the columns. And this made sense to me that grid systems would become hugely popular at this point because we were using floats And we were dealing with lots of browser bugs with floats. So every time you made a float, you had to set it to display inline, and then you had to handle various bugs across different browsers, and it was a mess. So these CSS frameworks, which were, as far as I recall, the first open source tools that we had as CSS developers. Maybe Eric Meyer's Reset was in there somewhere. But these allowed us to skip most of the hacks and ignore that part of the process, which was nice. So those became very big. That's the same time that I was actually starting my company. And I saw this talk not live because I was not in London, but thanks to the internet. If you ever have a chance to watch this talk, it's still relevant. There's a few things in it that are out of date since 2008, but Natalie Down was proposing a different way of working with CSS, moving away from those frameworks that were a library of CSS code. And with plain CSS, all that we have is an API. When we give you a CSS framework, the only API available is selectors. So these were just lists of selectors that you could use, and some people still use things like that today. She was proposing that instead of a library full of selectors, we could instead have a system and use consistent systems. So that would be more like BEM or OOCSS. Now, OOCSS had its framework, but sort of these systems of thinking about CSS, systems of naming things, conventions that we can use across every site to build consistent grids without having to use the same grid for every site that we work on. So she was also working with fluid grids. She would put fluid percent-based grids inside of a M-based container, and that way it was responsive to both font size and window size. And this was before responsive trademark became a thing. And really, the basic difference with responsive was that it involved media queries. I used her system quite a bit, but the math was really ugly. I simplified it here, target divided by context times 100%. That's how you do fluid math. But figuring out what context and target is, once you include gutters, can be very complex. And at that point, we didn't have Sass, so actually I think it existed, but nobody knew about it. So my CSS looked like this. I was typing that into a calculator and then copying and pasting it, and nobody had any idea what my CSS meant. There's no way to know what that's for. Soon after that, Compass and Sass did become more popular, and finally our CSS is Turing complete. It sort of breaks that principle of least power. But I looked at that and said, okay, great. I can start writing out my math. That's meaningful. Not perfect. So that's where Susie came in. I wrote Susie just to take that math and make it readable. That was the entire point. It only does that one equation. Good, done. But what we're going for is code that's readable both to humans and to machines. That's what we want. From the start, we want code that can be read by other developers as well as read by our browsers so that it's rendered. And that's the goal, and Sass helps with that. We're naming things. We get to take this HSL, which some people aren't going to understand necessarily what exactly color that is, and we give it a name, and we say not only what color is this, but we can say what do we use it for? Why is it here? We can give it a purpose. So as Sarah Drasner says, code is communication, and I always have to mention she only said that once, and she complains every time I quote her on it. So sorry, Sarah. In 2009, we get media queries, and then in 2011, we get calc. And calc is really interesting, and it has been around for quite a while and well supported, more than it's used. Calc gives us the first ability to mix units in our CSS. Finally, we can add a pixel to a percentage and get a result. Because calc is calculated by the browser has access to the DOM, it can figure out both of these numbers and then add them together. So that's something that Sass will never be able to do because Sass will never have access to the browser. Given all of those pieces, Ethan Marcotte writes his article, gives a talk, announces responsive web design, basically saying we need to target all these things. And this is a fraction of what we're looking at. And it's not just devices. We're trying to go beyond targeting one man with yellow hair and beyond this and beyond this. And, you know, we don't even know things about these people just from their pictures, but we're trying to target lots of people in lots of places. So we need to remember that though CSS has a declarative syntax, CSS is in no way static. CSS is built from the start, it is built to give us ability to make change and to style change. How does this look different in one place versus another place? And those are the sorts of rules that we're writing in CSS. It's not, here's how it is forever, but here's how it should handle different situations. That's what CSS is written for. So part of that is going with the flow. You may know the concept of the flow. These things are in an inline flow, and they move in relationship to each other. We can toggle that to a block flow and see that they move in a different axis. But the flow is useful because it sets up relationships between objects rather than having each object on its own on the page. If each object was on its own, when I changed the size of one, I would have to hard code the size change for every other object in the flow. But the flow gives us ability to just let those relationships move. So responsive design said we're going to use fluid grids, flexible images, and media queries to manage how the flow changes at different size screens on different devices. That was a new idea, putting all that together. It's interesting, media queries were available much earlier, but nobody was really paying attention to them until Ethan wrote that article. In 2014, and I was surprised by how long ago this was, we got CSS variables, Firefox 31. Unless you count current color. Current color has been a variable that we've had since the beginning. It stores the current color in your CSS, and that's figured out by where you are in the DOM, not just where you are in the CSS file. But a variable we didn't have access to changing at that point. Now we have access to change these. And Tab Atkins wrote the spec for this. It looks like this. You can define a color, and you can then call it. So it's basically an empty browser prefix on a property. And the goal there, he says, was that he was actually trying to slip in a new feature called custom properties. Nobody would go for it. He called it variables, and they bought it. So he's now working on the next step of that, which is to make it more powerful as a custom property. This is how you access it. You use the var function in CSS now. You can call the property name, and then you can also give it a fallback. So that's useful if the property may or may not be defined. In some ways, that's similar to variables in Sass. We've all worked with variables before. I hear JavaScript also has variables, though I can't guarantee it. So Sass variables were rad. When we got those, we were able to clean up a lot of our code. They hold data. They're useful for that. They store something. They make it reusable. They help us make our code more dry. That's great. But Sass variables use scope the way we understand it in most languages, where we look at the file and we can see the scope. Because columns 2 is defined inside of example, and even though nested class is nested in the DOM, we don't know that it's nested in our code, so it has no access to columns 2. And when we change something at a media query, we can change the value of columns there, but it only changes for that scope. So it, again, isn't changing for everything in the media query or everything that uses it. It has no access to the DOM. It's just scoped in the file like we would with in other programming languages. That's the big difference here with CSS variables. We finally have a way of scoping to the DOM the same way that CSS does, that cascade that we're used to, or maybe not used to. So what that means is that when we set columns 2 in example, all of the children nodes in the DOM of example will have that value, even if they are not nested in the style sheet. And that means that we can now change a value, add a media query, and have that trickle down to everything at that size in the browser. So that's a very different way that these work and really changes how we think about them and how we use them. In order for them, by default, they inherit everywhere. If we put them in the root tag, then I really mean everywhere. That makes this color available throughout our entire document. So that's something that we can do. If we really don't want things to inherit, we can set them to reset to their initial value on every property. So this is a useful way to say certain things should not inherit. Let's reset them every time if you need that. One of the things that I most love about them and have started using them for right away is that they make inline styles totally safe. There's always been a problem with inline styles being too specific. It's impossible to override an inline style if you need to. But when you're just defining a variable inline, you don't need to override it. You can just ignore it. So it's totally safe to set any variables you want to in your HTML, which is a great way to pass data between JavaScript and CSS. You can set the variable in the HTML. It's totally safe. CSS can ignore it when it needs to, has access to it when it wants, and you're still separating those concerns while communicating between them. Yeah, I already showed you how to use them, so I don't know what this slide is for. So I'll just give you a moment with it while I have a drink. Think on that, you know? What about that fallback color? It's a bit bright. Right, so you can call it there or you can ignore it. So that was the point of those, and I just should have gone through my slides faster. Another thing that you can do that I've used it for a lot is if I don't want excessive nesting in my CSS, if I don't want really specific long selector strings, I can avoid it by changing a variable at the root string where I want it to change, and then just grabbing that variable in the button. So I can suddenly make buttons look different in different places without adding any specificity to my button selector. I like that. That's a really nice way to avoid increasing specificity when you don't want to. Another way to use it, you can start to create defaults where they're missing and missing longhand. So box shadow, for example, only has the shorthand property. If you wanted to change any one part of a box shadow, you would have to redefine the entire box shadow. But with variables, we can set each property as a variable, and then we have access to change that variable individually. That's also really useful for things like transition, transform, that have different properties you want to transform. And then a last way, and this is less and less needed, this auto-prefixing, but you can create mix-ins in a way. If you have multiple properties that need the same value, we can use them that way, like we would use mix-ins in Sass. But where I start to get excited is when we start combining them with calculations. So now I can pass data in to CSS and manipulate it and return a new value. As a test, the first thing I did was I rebuilt Susie entirely in CSS. There's no Sass involved here. And it works. In fact, the background images are also generated by CSS variables, calc, and a background gradient. And you can see the full demo there if you go to the link. And this is how it works. I'm just setting the same global settings that Susie has. the columns, the gutter, the spread, the container spread, and then I have 50 of these functions or so. The interesting thing about using CSS variables as functions is that they can only hold one value at a time. So you can only have one calculation per element, which is not particularly useful, but it works. So then in using it, this is all of the code for defining the final layout. I just set how many columns there are, and then say how many I want to span, and I can change how many columns are available for nested context, and all of that works very smoothly. So, and then the background image also uses that and calculates out the background. Don't use it. Really, like, this is overkill. It's totally not worthwhile, but that concept is useful. If you do want a grid system in your HTML, passing in columns and gutters, and then defining how they're used in the CSS, that's a good way to go. The reason you shouldn't use mine is because I tried to solve all layout problems at once, and you don't need to solve all layout problems at once. You have your one layout problem. Another thing that I just started playing with, and there's an article on CSS Tricks that inspired some of this, is manipulating individual values of the HSL function as variables, and then getting to change them individually. For example, creating a darken and a complement, and being able to use those where I want, so I can start to create a theme based on CSS variables. So the fun thing that they were showing in the article is the way you can use clamped values. So this would be to say the color wheel, no, the lightness scale from 0 to 100 will clamp at 0 and 100. So if you go under 0, it will stay at 0. If you go over 100, it will stay at 100. So you can use that to toggle back and forth between a black and a white by multiplying with a negative value or with a positive value. You can do something similar with the color wheel. If you go over 360, you're still on the wheel, so you can simply add to get the complement. So here's a little tool that I built that just lets me adjust. So the threshold is where we're doing the toggle. What lightness do we want to switch our main color at? And then as we change color, when we go past the threshold, we change. So this is a rudimentary way of doing color ratio accessibility. It fails a little bit because you'll notice that if we have a blue and a yellow, say, there are different times when they ought to switch. So it's not perfect because we don't actually see color purely by lightness. So again, probably not useful right away, but the concept is fun to play with. We can now start creating themes purely in our CSS, passing in one color and generating the other colors that we need. Through JavaScript, I hear this is a JavaScript conference, so I threw in this slide. You can access and change the custom properties like you would access and change any other property in CSS. There's a lot more coming. Sorry, that's all that I know. I've only been introduced. And actually, I should jump to this one first. There's a lot more coming in terms of JavaScript manipulation of CSS variables. Right now, it's all behind a flag in Chrome, but you can start playing with it. It's called Houdini because it helps you escape from the confines of CSS. Something. So there's a few issues when you start playing, a few gotchas. Types aren't defined currently, and that's part of what Houdini is going to help us solve. So when I put in a string or a color, CSS doesn't yet know, the browser doesn't yet know what it is, so it has trouble animating it. So at this point, you have to animate the property that it's put on, not the CSS variable itself, because the browser doesn't know how to animate an unknown type. They don't work inside of the URL function, which is too bad. I've had problems with that several times. And then another thing you'll notice, the var size m, I can't concatenate things like that. So I have to use instead calc var size times 1m. The browser can do that math, adding an m unit that way, but it can't do string concatenation. So that's unfortunate. Hopefully we'll get that eventually. Part of what we're going to get from Houdini is this ability to register properties and define their syntax, define their type, and that will start to allow the browser to do some of these things that we can't yet do. If I were Tab, I would show you a demo of that, but I'm not. You can learn a lot more from Leah Veru on this. She's done some amazing talks that just dive into variables and everything you can do with them. And if you've never seen her talks are amazing. She live codes the whole thing, and I can't. So I'm going to start to put that together with CSS Grid instead of going more into depth with that. CSS Grid was fun because it suddenly landed in 3 browsers all at once in March of 2017. It was one day not usable, and the next day I woke up and could use Grid in production, which was fun. We're in the future now, or more relatable, we're in the future now. That boat is awesome. Whoever built that. There is seriously nothing like it. So when CSS Grid landed, I stopped getting invited to conferences because I was known for Susie, and Susie was dead that day. Like, that was it. CSS Grid is totally unique. It can do way more than any Sass library that there is. If any Sass library claims or what's that other one? Post-CSS. If any of them claim that they can do what CSS Grid does, they're lying to you. Don't believe them. It's really unique. Because all of the calculations are run by the browser, it has access to the DOM. It can do mixed units in a way that nothing else can. The spec is very complex, and I've seen lots of talks on Grid go into detail on the spec, and people are scared away. Getting started doesn't have to be reading the whole spec. There's a lot of ways to get started very quickly. It basically looks like this. The grid is defined on the container. So you can say display grid. It's just a display property. You can define columns and rows. I only showed columns there, but our normal historic 12-column grid, we can create with that line of code, repeat 12 one fraction, and then we can put in gutters without having to do any math of our own. Optionally, so that was defining it on the container. Optionally, we can pass control of sizing on the grid back to our elements using the auto keyword. And so what auto does is it just returns to the flow. What would this element do naturally on its own? And we looked at the flow earlier on the inline axis and on the block axis. If it's confusing, there are several different units in CSS now that all have to do with percentages of the space. This is your cheat sheet for them. So a percent is relative to the parent width. Actually, that's available space in the parent, so that wouldn't include padding. The VW unit is relative to the entire viewport. So 100 VW is the entire width of the window. And fraction is the new one added in CSS Grid. And what it means is how to share remaining space. So a fraction unit takes up a percentage of remaining space. That's similar if you've used Flexbox to the flex grow and flex shrink, which have no units. It's exactly the same context. How fast should this shrink or grow to give up or take up remaining space? One tricky thing about the fraction unit, if you define something as one fraction, it automatically assumes you mean min-max auto one fraction. So it will only grow and not shrink because auto is the minimum and then it's allowed to grow to one fraction. So if you actually want something to shrink and grow, you have to set a new minimum. So I have quite a few of these in my code, min, max, 0 on fraction to allow something to shrink completely. Grids, once you define a grid, you get a layout like this. You have your grid lines, and they're 1 indexed, and then they're also -1 indexed. So you can access them from the front or from the back. And you have this sort of single source of truth that you can create. This is starting to build out more complex, defining different parts of how we're going to relate to this grid. But we can basically draw this ASCII art of our layout and then say the header takes up both columns and is sized auto for its vertical. And then nav is on one side, main is on the other side, and then the footer goes across again. And then we define the column widths at the bottom. And then for the layout, similar to the Suzy demonstration, we just pass in the name, and it automatically goes there. And actually, this ignores the order of the elements in the DOM. So no matter what order these are in the DOM, we can pass them to the right area of the grid. So there's a lot of power there. Be careful with mixing up code order, DOM order, and visual order, but there's good reasons for it sometimes. So right away with those couple lines of code, we have a full standard layout, and that's it. And really, CSS developers are all going to get fired because this is going to be just too easy. So Jen Simmons, who's been doing lots of the work on the grid spec and on informing people about it, has started to call this intrinsic web design, the next step after responsive. So instead of just being fluid, it's both fluid and fixed. We can mix the two now. They can live together. We're dealing with stages of squishiness. So something can be fixed, or it can use fractions to take up remaining space to be somewhat fluid. We can use min-max to let something be fluid until it is fixed. And we can use auto to return to the flow. So we've got all these different stages of how we're handling squishiness in our elements. We finally have truly two-dimensional layouts. We get columns and rows, which is totally new in CSS. Revolutionary, 2 dimensions. And we can start to mix these things. There's no reason that floats are gone forever. I've already heard some people talking about floats like we talked about tables for a little, where a teacher was refusing to allow their students to float anything. That's absurd. Floats are still useful for what they were invented for, which is floating images in text. They have a narrower use case. They're not gone. But we can start to mix these things. So when we want things to align and flow in 1 dimension, Flexbox is better for that. When we want to go into 2 dimensions, Grid works great. Sometimes I go back and forth on those between whether I want to define the spacing from the child or from the parent. So there's different reasons to use them, and we can start to nest those and get different outcomes. We can expand and contract our content in new ways. We can change justification very simply. We can change how things wrap for the flow. We can start to flex things using the fraction unit, et cetera. And then media queries are only needed sometimes because we get things like autofit and autofill that figure out for us how many columns we have space for. And then it just fills them in, which can be really useful for something like image gallery or masonry-like layout. But I want to put all these things together, and we started playing with this right away on a client project last year, being able to pass in values from JavaScript, just pure data, gets passed in. We're building a scheduling app. We want to know when an event starts and how long it is. So we pass that in as CSS variables, and using calc and grid, we manipulate that data, and we can say, we have this many minutes in a day. Let's create a column on the grid for every minute of the day. And then we're just passing in a start and an end, and we use those as grid lines. to tell every session on this schedule where to start and end. So we got a layout in about 10 minutes using just some CSS variables and some grid, and it builds our schedule for us, which I love. The limitation here is, I don't remember the exact number. We were able to do 16 hours, and then you hit the limit of how many columns a grid can have. So if you need a 24-hour, you're going to have to step back a level and do 2 minutes per column. But you can get to 16 hours worth of grid. Then I played with this with bar charts. This is just the HTML for a bar chart. You could also use tables for this. I decided on definition lists, but just some simple semantic markup. And I pass in the value of 45, value 100, and I can even change the scale up top in my chart. Then this is the math. I take each chart starts at the scale +1 because to handle the indexing minus the value of where we're wanting to start. And again, I played then with how it adjusts color based on the value that's passed in, and using just those variables, I have this completely fluid grid. And I'm actually going to inspect it here so that I can, let's see, where's the scale? Let's change that to 200. There we go. And everything adjusts. So I don't know why you need to change the scale on your chart, but you can. I love this idea of being able to manipulate raw data in CSS so that JavaScript only has to pass us what is known, and then the styles can decide how actually to use that data to generate something. Next, I want to play with, see if I can do line graphs and plot charts. I think plot charts will be easy and line graphs will be much more difficult. But have fun with that. Start playing with those things. Here's another one that I did. Somebody presented some generated art they had done. So I redid it in View, and I can start adding invaders or removing invaders. And I can click on them to change them, and I can shuffle them, and then I can kick ass and like drive around shooting them. Yes, yeah, get them. So that's important. If you want to dig more into grids, gridbyexample.com is a great place to go. This is Rachel Andrews' site. It has not only lessons on the different aspects of a grid, but also common layouts built in grid with fallbacks already built. So if you have one of the common layout needs or something similar to it, you can copy and paste her code and already have your layout written. Also, Jen Simmons has youtube.com/layoutland, where she does various YouTube videos going into much more detail. She also has Jen Simmons Labs, where you can see lots of experiments, her doing various art sites, playing with what grid can do. So I just want to remind you, CSS is in fact awesome. Thank you.